This lesson is about electric field lines. Let's understand what are field lines and go through the properties associated with them and then through some examples. Alright, so the field lines are vectors that we use to represent the electric fields. And this representation are arrows that have length proportional to their magnitude and that point in the correct direction. So here are some examples of the electric field lines of point charges isolated in space. Alright, they're not interacting with anything else here. So keep in mind that for positive charges, the arrows, the vectors are pointing outwards, and for negative charges, the vectors are pointing inwards. And the greater, the strengther the field is, more arrows you have. These are for pointing charges. Now, for example, here we have the electric field lines for 2 point charges that are interacting with each other. So for 2 positives or 2 negative charges, we have repelling field lines, and for opposite charges, we have field lines that are attracting each other, right? It goes from one to the other charge. We also have, depending on the format of the thing, of the plane you're dealing, we have different formats of and different types of representation of field lines, okay? Here is an example of the field lines, the electric field of an electric charge cylinder. Alright, now let's talk about the properties of these field lines. First, we need to know that field lines must begin on positive charges and terminate on negative charges, or at infinity, that these are the cases we've seen before in the examples before, where we have just an isolated charge. Alright? So begin on positive, terminate on negative. Also, the number of field lines leaving a positive charge or entering a negative charge is proportional to the magnitude of the charge. In other words, if you have more field lines, you have greater charges, right? More field lines, greater the charge. Also, the strength of the field is proportional to the closeness of the field lines. So, if you have closer lines, field lines, you have a stronger field, alright? And it's proportional to the number of lines per unit area perpendicular to the lines. So if you're in a point where the field lines are very close, it means that the field, the electric field, is also strong, okay? And last, the direction of the electric charge is tangent to the field line at any points in space, and the field lines can never cross, alright? These are the properties of electric field lines we need to know in order to better understand the lines we've just seen, okay? Okay, so let's go through this example here. So this figure shows the electric field lines near 2 charges, Q1 on the left side and Q2 on the right side. The question is, what is the ratio of their magnitudes? Okay, so let's take a look into this image here. We can see we're dealing with 2 different charges, a positive and a negative one. And, well, the field lines are coming out of the positive charges and entering the negative charge. So everything is alright here. Also, just by looking, you can still have much more lines coming out of the positive charge than lines entering the negative charges. And this shows us that the positive charge, the positive electric field is stronger than the electric field of the negative charge. All right? So if you count the number of lines here, we can count 31 field lines for the positive charge. And for the negative charge, we have 12 lines. So to calculate the ratio, we can just divide 31 by 12. And we have that this ratio is approximately 2.6. And it means that the positive electric field, in this case, associated with this positive charge, is 2.6 greater than the electric field of the negative charge. Alright, now it's your turn. So take a look into this picture here. We have two positive charges. They are the same magnitude, okay, and they are interacting with each other. We have all the lines here from the electric field, okay. Also, we have some points A, B, C, D, and E in different positions here in the electric field, okay. So I want you to look at this image at these points in space and rank these locations in order of the electric field strength from smallest to the largest. Okay? Remember all the properties we've seen from electric charges and think about it, write your answers in the comment sections.
If you enjoyed this video, don't forget to subscribe and stay tuned.